Okay, so today we are going to look at multiplying three factors. Sometimes you might choose to multiply two numbers before you multiply the other number. So if we have a problem that is 3 times 3 times 2, we can actually multiply the 3 times 3 first if we wanted, or we can multiply the 3 times 2 first. It doesn't really matter what order we multiply the factors. So starting off, let's multiply 3 times 3 first. So I like to put parentheses around what I'm going to multiply first. That's just a good visual of that. That's what I'm going to start with. So 3 times 3, which is 9. And I'm always write down what I solved underneath it. And I still have to multiply that by 2. So I'm going to write times 2. So now I can multiply 9 times 2, which is 18. I can take that same problem, 3 times 3 times 2, but instead of multiplying the 3 times 3 first, I can multiply the 3 times 2 first. So this would be yet another way to show the same problem, but calculating a different way. So starting off with 3 times 2. 3 times 2 is 6. And I still need to multiply that by 3. So now I'm left with 3 times 6, which gives me 18. So with this problem, I could also even change the order of the factors. Because as you know, with a commutative property, changing the order of the factors doesn't change the problem. And that's essentially what we're doing here. So I could even rewrite it if I wanted to look like this. 2 times 3 times 3. It's still the exact same problem because I have 1, 2, and I have 2 3s. There's my 1, 2, and there's my 2 3s. So it's all the same. Let's do another one. 5 times 4 times 7. So 5 times 4 times 7. Well, I'm actually going to choose something that's relatively easy for me to multiply first. So that might be how you decide what to multiply first. So for me, 5s are pretty easy. So if I have 4 5s, I know that I can count by 5s 4 times to give me that answer. 5, 10, 15, 20. Hopefully at this point, you guys know your multiples of 5 by now. And if you have 4 of them, then you get 20. So now I'm left with 20 times 7. Now, when you're multiplying multiples of 10, they're easy too. Just imagine there's no 0 there. And we have a 2 times 7. That 2 times 7 will give us 14. And after we do that multiplication, we have 1 0 to add into the ones place. So 14, I add that 0 in my ones place to give me my product of 140. So maybe I'm going to do my 4 times 7 first now. So 5 times 4 times 7. I'm going to multiply my 4 times 7 first. That gives me 28. And then I multiply that by 5. Oh man, that's definitely a harder multiplication problem for me to do. So if you get to an incident like this and you realize, oh man, I don't know how to do my double digit multiplication yet, maybe you want to go and do it the other route. But remember, multiplication is the same thing as repeated addition. So we can take that 28 and add it to itself 5 times to find that answer. 28 plus 28. I could do that, and then I can do it another 2 more times. And then I would just have to add one more 28 to it. So if I have 28 plus 28, that gives me 56. And I know that 28 plus 28 is 56. And then I add those two together, 56 plus 56, which gives me 112, and I have to add one more 28. 112. 8 plus 2 is 10. Carry my 1. That is 4, and I get 140. I get the same exact answer. If you're ready for long digit multiplication, you could do that route. 28 times 5. 5 times 8, you start multiplying the ones times the ones. 5 times 8 is 40. Carry my 4. 5 times 2 is 10. Add the 4, which is 14. So all of these different ways to solve the same exact problem. So remember the commutative property. Changing the order of the factors doesn't change the product.